Okay. So, in the association analysis last class session, you have absorbed how to find association or pairings in between the elements or items in a particular transaction. So, if you have multiple items in a transaction, how you can do pairings based on the support and confidence. And in that measure, we have observed how the a priori algorithm works to find out the frequent item set in a given transaction. So here in a large item set mining or frequent item set mining, we usually what we do, we have a transaction in this way. There are 1, 2, 3, 4, 5 transactions, and in each transaction, the items are being purchased together the way it has been provided in the table. And if you want to find all the large or frequent item sets, which items are purchased frequently, that let's say that you want to determine. So best, so if you want to determine the frequent item sets, then first you need to consider a threshold or support. Okay, the support count. So that let's say in a condition you are looking for a support count threshold which is greater than or equal to 3. So any item below 3 support count will not be considered in the frequent item set. That is our basic definition. So in a priori, there are two different disadvantages. So in each step, you are you are generating the candidates and then generating the next frequent item set. Okay, so candidate generation, large item set generation. So each step you are joining different items and again pruning or extracting or deleting the items. Those are below the support threshold. So the first disadvantage is it's bit expensive to handle large number of candidate sets in a transaction, and it can be complex and tedious also to scan through all the elements and check their in the database and check the candidate patterns, in what pattern they are occurring actually. So each time you have to determine the candidate set and the frequent item sets. So it's kind of time consuming and expensive also. So, because of that, there is another one way, FP tree. Again, this is different to your a priori. And in the FP tree, we usually scan the database once to store all the important information in a tree format. That is called frequent pattern tree, or the short form is FP tree. And it's more concise and it can directly generate large item sets. Uh, so let's take the same example that I was showing in the first slide. Suppose this is your transaction given, 5 transaction, and the support threshold we are determining or considering as greater than or equal to 3. Any support count less than 3 will be discarded. Just remember that. First step or the algorithm of the FP tree. You need to find out the ordered frequent sets. For items with same frequency, the order is given by alphabetical order. How to deduce the ordered frequent items? Let's see that. The first step, this is your transaction given. So I'm just writing down the transaction over here, the 5 transactions. Now the threshold actually we are determining as, yeah, so we are determining as 3 or assuming as 3, and first we will find out what are the occurrences of each item that you find here in the transaction table. So A is occurring how many times? 1, 2, 3, 4. B is occurring 1, 2, 3, 4. Like this, you will write down all the frequency or occurrences of each item. Understood? It's simple. Once you do that, compare which frequency are less than 3. Any frequency greater than or equal to the support threshold will be kept and all others will be discarded. So we have 1, 1, 1, 1, 1. All those items are discarded, and now you have the resultant table in this way. A, B, D, E, F, G. Now we will begin FP tree construction using all those. So before that, whatever items you found, now just take all those items, and after discarding the minimum support count items, and now create your ordered frequent items. So for first item set, we have A, B, C we are not considering, so we will leave that. Then we have D, we have E, we have F, we have G, but we don't have H. So we will only, for a given transaction in the main transaction table, we will include only those frequent items whose frequency is greater than the minimum threshold, equal to or greater than the minimum threshold. So any question at this point? So using the same method, you will just find out the ordered frequent items for all the rest of the transactions. Now let's see what happens. Okay, prune and keep only items frequency that I just told you. So next step, so whatever you got, whatever you deduced in the first step, we are going to construct the FP tree from the above data. How? Let's see that. First, we are considering the threshold as 3. So whatever you got, put it in a table, item spot and the frequent item set that you found out in the last step. Now, for the first ordered frequent item, that is A, B, D, E, F, G, first let's build the FP tree. How to do that? See that. First you will have a null set or the root. Okay. Then from root, we are just considering this one, A, B, D, E, F, G. So let me annotate it. So first A, so we have this A here and its support count 1 will be directly appended. Okay. Then we have B, so 1 is the support count. We have D, then comes E, then comes F, then comes G. So it will always start with the left node. Okay. So by default, we have to follow this process. Now, let's consider for the second order frequent items, first order frequent items A, B, D, E, F, G. Let's build the FP tree. One moment. Okay, sorry, it should be actually by mistake, it is A, B, D, E, F, G. I will correct that. It should be A, F, G actually. Okay, only A, F, G. So we are considering this second one. Then we will do the third one, then fourth one, then fifth one. Okay, sorry about that. So yeah, so for the AFG, we will now build the FP tree from the initial point that we are here. So okay, so initially we have this from the first step. Now AFG. So where should the A actually begin? Let's see that it will again start from the root and A will be now overwritten by 2. The support count will be increased to 2. Now if it will come to right side, then G will start after that if. Next, we will take B, D, E, F. That is the third one, third ordered frequent item set. We will build the FP tree from there. Whatever you have initial step. This is the latest step. B, D, E, F. So where should we connect the B? Okay. Always it will start with the root. So now you will start with the right child. B, D, E, F, and the support count will be 1 each time because we don't have any other combination before that. Now, the next transaction, if you see ABD, for that we are doing. So this is what we have from the previous step, the FE tree, the ABD. Where should we start? So if you see this one, yeah. So this is the step, last step. So when you have ABD, actually A will, there is a connection. So it will start from here. A will be 3, B will be 2, and D will be 2. So that is what we are having here, A3, B2, D2. Next, we have A, B, E, G. So for A, B, E, G, what we will do, is there a connection? Yes, A is already there. So we will just increase support count, 4. Now next, do you have B after that? Yes, it is there. So B support count will be increased to 3. Then E. Is there a connection from B to E? No. So we will have to make a connection. E1, then G1. After you are done with this part, next, we will just connect all the nodes to the head of the node link. So like this, you will make the path. I mean, there should be a path from each node to any other part of the tree in this way. To A, then this is B. So actually this will give you how many support count is actually there in the tree for every item. For A, for B, for D, for E. Like this, there should be a connection. Next step, from the previous FP tree, we will build the conditional FP tree for each item. Okay. Just one moment. Okay. So third step. So this is your given tree that we got from the last all the steps. So first building the conditional FP tree. So what is this conditional FP tree? First, we will start with the leaf node. In the last, you have G. Okay. So there are how many occurrences actually? 3 occurrences, 1, 2, and 3. So if 3 occurrences are there, for each occurrences, you have to write down the paths actually. So for the first one, A, B, D, E, F, G. So A1, B1, D1, E1, F1, G1. And then for this one, A, B, E, G and AFG. Okay, now you just count all of them and write down their frequencies. A occurring 3 times, B 2 times, D 1 time, E 2 times, F 2 times, and G 3 times. Correct? Now from there, find out the item and frequency of the item, all the items whose threshold is actually equal to or greater than 3. We will just only keep those. So now we are only left with A and G. What should we do? What should be the resultant tree now? So G is already there. So A will be the previous node for the G. So this is the conditional FP tree for G. So like this, we will make the conditional F tree for F, E, D, B, A. Let's see them one by one. So for F, we are going to see F. So this is one path, this is one path, and this one is one path. There are 3 paths. A, B, D, E, A, B, D, E, F, G. Sorry, A, B, D, E, F. Only we will stop at F because we are making the conditional F tree on F. Then A, F, then B, D, E, F. Okay. This is what we have here. Now write down the frequencies and filter out those frequencies which are only greater than or equal to 3. So we have only F, that is 3. That is why it will have only the root. The node itself will not be considered. Okay. Then comes E. So for E, how many paths? 1, 2, 3. Okay, these 3 paths are written here. Determine frequencies, then filter out frequencies. Only B and E. So E will have the root node and the B node. So this is the conditional FP tree for E. Okay. Then comes D. So for D, how many paths are there? A, B, D, B, D. Okay, these 2. Write down the frequencies, filter out frequencies greater than or equal to 3. Now make the root. So D is the conditional FP tree, so don't consider that, only consider the node that is B. So this is the conditional FP tree. So after D, we have the next node, that is B. So we are doing for B now. So for the given tree, how many paths? A, B, and only B. So here A, B, the last part, it should be A3, B3 support count, and this is 1. So just write down all the support counts and filter out the support counts where their frequencies are greater than equal to 3. Now B has only one node left with it, that is A. So this is the conditional FP tree for this. Last node is A. So node A. So at last, what is the support count? 4 in the last step. So A4 will be only included in the conditional FP tree. So the same node will not be considered, and we will only be left with this root node. Okay. So after whatever you have got, now determine all the frequent patterns. See here. So whatever we did in all the last slides for G, for F, for E, D, B, and A, all their deduced support counts and their conditional FP trees are written here. So you got the frequency of A as 3, B as 3, okay, A, F, E. So everyone has their own frequency or support counts along with their conditional FP trees. Now from this, if you see whatever you see here, that is just written over here. So from this we got that for G3 we got G3 and A3. Okay, this is the frequent item set. For E3 we got BE3. So we have to include this F3. Yeah, sorry, the F will not be included because it doesn't have a root node besides its only itself. Then for E, it is BE. For D, yeah, so for D, it is DB3. For B, it is 4. And AB, it is 3. Okay, count 3. And for A, it is 4 only. So these are all the frequent item sets we found out. See, there are two different ways. Either you follow a priori for finding out this frequent item sets, or you follow FP tree. Whichever way is easier for you, you can follow that. Now, what is the complexity of FP tree? So in the last a priori algorithm, you have been generating the candidate item sets and the frequent item sets. But here you are just making two iterations for the on the transaction database and constructing the FP tree directly. Okay. But for inserting one transaction, you are going to consider the number of frequent items in the transaction. Then size and the height of FP tree, it is always it always depends on the what is the frequency or the occurrence of all the frequent items in the database, and whatever is the largest or maximum number of frequent items in any transaction in database, that will be your height of the tree. That is your size and height of FP tree. Next comes the advantages and disadvantages. So FP tree algorithm, it only scans through or iterates through the database only twice, whereas a priori algorithm scans or makes scans through the transaction in every iteration. So a priori is more expensive. Then here pairing of items is not done like in the case of your a priori. It is stored in a compact version and it is more efficient for large item set or long or short frequent item patterns. Then disadvantage are it is a bit difficult to build the FP tree for every item. That is another one disadvantage, and it Sometimes if you have a large set of data items, then it can be expensive. Okay, and in that case you may approach to your a priori algorithm. Okay. So these are the basic steps. Actually, I'll be giving you some problems based on this, some assignment. So in here, do you have any question in this epi tree construction?